representative of the human condition. It's not a perfect representation, obviously, but see if you can follow me on what we're trying to show you here. What I got my hands around here would represent the thorax, the rib cage, and vertebral column, right? That's what this is. This tube here would represent the trachea, would it not? If you'll notice, this is a Y-shaped tube that's inverted. So this tube has two branches here. Those two extensions of this tube would be the primary or main stem bronchi. The balloons are going to represent the lungs. That thing down there is going to represent the diaphragm. You got it? All right. Now, what causes air to move from out here into your lungs?
Inspiration.
A change? No, inspiration is the act.
Sorry.
What makes air flow from out here to in here is a change in pressure. Air, like blood, always flows from an area of higher pressure to an area of lower pressure. When you breathe in, your rib cage moves out and forward, and your diaphragm moves down. Right? When that happens, you're increasing the volume inside here, inside your rib cage. You're increasing the volume. One of the principles of gas movement is that as you increase the volume, you decrease the pressure. Because as you increase the volume, these molecules of air are not bumping off each other as much. So the pressure goes down. When you increase the volume, pressure goes down. Conversely, when you decrease volume in a closed space, pressure goes up. So when you breathe in, the rib cage goes out and forward. Your diaphragm goes down. You've increased the volume in here, haven't you? And concomitant with that, the pressure in here drops slightly. It doesn't have to drop much. In fact, it doesn't drop much. But when the pressure in here drops lower than the pressure out here, air moves in. When you breathe out, in other words, when you relax, take a breath in, muscles are moving. When you relax, your muscles relax, so your rib cage moves in and back, and your diaphragm moves up. Now you've decreased the volume in here, and the pressure rises slightly, just enough to make air go from in here out here. You follow me with this? Because you're going to need to explain this on a landing thing. So let's look at how it happens. Granted, this is not a perfect model, but this is what we're trying to demonstrate. So let's say that we have breathed out and our lungs have collapsed. See the balloons collapse? Because I moved the diaphragm up, didn't I? Now I can't make this get smaller, but when we breathe, when we relax, our ribs move in and back, right? And the diaphragm moves up. So we're increasing pressure, and air moves out of the lungs. You with me so far? Mm-hmm. Now, when we take a breath in, the the rib cage is going to expand, the diaphragm is going to move down. We've increased the volume in here, haven't we? And the pressure dropped. Not much, but just enough to move air into the lungs. When we relax, pressure rises slightly, air moves out. So, you need to be able to correlate the parts of this model with human parts. So this is trachea. Well, this whole glass tube is trachea and main stem bronchi. You with me on that? All right. The balloons of the lungs, this casing here is the rib cage, and this down here is diaphragm. All right. Now, you got to correlate pressure changes with air movement. So when we breathe in, rib cage moves out and forward, diaphragm moves down. We've expanded the volume inside here, right? Pressure drops slightly. Air moves in. When we relax, ribs move in and back, diaphragm moves up. We've increased the pressure. We've decreased the volume and increased the pressure slightly, and air moves out. Does that make sense? Understand this, because if there are a couple of questions about this on the lab exam, and if you're not straight on it, you're going to be confused about the question. All right? Okay.